I will tell you what is pharmacology and what is investigate. Pharmacology is a science which investigates drugs, how drugs affect in organism and how organism affects on drug. How drugs affect in organism, we investigate in pharmacodynamics, and how drugs affects on organism, we invest in pharmacokinetics. And in pharmacodynamics, we learned in our group some topics which we had in our this year, and our students today prepared some presentations of some subjects which we had these semesters. Today we will have presentations about hemostasis, about ulcer, about pain and drugs which affect on pain, analgesics, about allergy, about any psychotic drugs, antipsychotic drugs, Parkinson's disease and epilepsy disease. And during this presentation and during this conference, we will discuss their pharmacokinetical and pharmacodynamical properties. These you can see here also, which we will see today, which we will listen today. And first group of drugs which we will discuss will be hemostasis and drugs which affect on hemostasis. Please.
And today I'm starting with my presentation with the hemostasis. So first of all, what is the hemostasis? It means prevention of blood loss from the vessels, and it is mainly achieved by the three main conditions, that is first of all vascular constriction, second is platelet plug formation, and third is blood coagulation. Now first, vascular constriction. It is a trauma to the vessel that causes the smooth muscles to contract, and it is mainly by the result of the three processes: local myogenic spasm, second is a factor from the traumatized tissue and platelets, and third is the nervous reflexes. And first of all, if you know about the vascular constriction, you have to know about what is the platelets or thrombocytes. It is mainly the smallest blood element, smallest formed element of the blood, mainly 1 to 4 micrometer. And it is mainly contains single karyocyte, megakaryocyte, also contains the hormone which is known as a thrombopoietin, and they are also removed from the circulation by the tissue macrophages, and they are generally 1.5 lakh to 3 lakh per microliter. And yes, they also contain the actin, myosin, and last is the thrombopoietin, and they contain the dense granules which contains the phospholipids, ADP, ATP, calcium, serotonin, and they also contains the alpha granules which contains the von Willebrand factor. It is the main important factor for the clot formation, and also they contain the clotting factors 5th and clotting factor 13, and also they contain a PDGF, which is a platelet derived growth factor. And function of these platelets are mainly serotonin released by these platelets contribute to the vasoconstriction, and platelets aggregate to the plug formation to the vascular injury. And platelets also provide the clotting factor, and they also contain a contractile protein, and they also stimulates the mitosis in the vascular walls. Next image. These are the steps how the platelets causes the blood coagulation. First of all, this platelet attaches to the collagen particles and granules attached to it. Then there is a receptor which is known as fibrinogen receptor, which attaches the fibrinogens to the endothelial cells, and this is how the platelet plug formation will be there. Next one. Now blood coagulation. But blood coagulation mainly occur due to the platelet activation factor, and they occur mainly in the three stages. First stage is the formation of the prothrombin activator, in which there are the two pathways, extensive pathway and second is intensive pathway. And then there is a conversion of prothrombin to the thrombin, and last there is a conversion of fibrinogen to the fibrin. Back, man. This is the first extensive pathway, in which the prothrombin, with the help of the prothrombin activator and the deposition of calcium, will be related to the thrombin formation, and this thrombin will convert the fibrinogen into the fibrinogen monomer, and there is after calcium deposition, the fibrin fiber, they will cross-link fibrin fiber formation by the fibrin stabilizing factor. These are the 17 platelet factors, and these are the first 13. Then there are the some 4 special factors like this HMW, pre-Ka, which is a pre-calcin, and which is also called as a Fletcher factor. There is a calcarine factor and platelet phospholipid also. This is the intensive pathway in which if you have read about the coagulation factors, then also this is very easy pathway in which 12 to 12 is converted by the this first HMW kinogen, which is now known as high molecular weight kinogen calcarine. It convert to 12A to 12 to 12A, and similar 11 to 11A. Like this, there is a conversion to up to 5 to 5A, and then this 5A will convert the prothrombin into the thrombin, and fibrinogen will be converted to fibrin, and similarly 12A will cause the fibrin to be stabilized, and then there is a cross-link formation of the network. Then after this, there is now formation of clots. After the formation of clots, now we have to dissolution of the clots. This dissolution of the clots, first it is composed of, like I told you about, the mesh network of the fibrins is formed in the clot formation. Then they will entrap the blood particles, cells, platelets, and also they will attract the plasma. Then large amount of plasminogen will be trapped into the clot. Now there is a special factor which is known as a tissue plasminogen factor activator, which will convert this plasminogen to the plasmin, and that plasmin will be digest from the fibers. And there are also some of the coagulant factors here, like 1, 2, 5, 8 and 12. These will help the plasmin to digest the fiber. Next one. Yes, now the prevention of the blood coagulation. Now if we also know about the prevention, if we not prevent the blood clot, you have learned about in some of the coronary artery or veins, if the clot formation will be there, then the person can die due to the heart attack or myocardial infarction. Now there is also some of the internal factor which will prevent the blood to not form further clot. First of all is the endothelial surface factor. It is the smoothness of the endothelial cells help to prevent the contraction of the activation of intrinsic clotting factor. Second is a layer of glycolex on the endothelium, which will causes the repels to the clotting factor and platelets. And third is a thrombomodelins, which bind thrombin, and this thrombomodelin thrombin complex will activate the protein to inactivating the factors of that factor 5 and factor 13. Now this is the 80 to 90% of the fibrin of the thrombin become absorbed in the fibrinogen, which will prevent the spread of the thrombin, which will prevent the excessive spread of clots. Now this is also one of the important antithrombin 3. This important factor, antithrombin 3 also prevent the blood coagulation, further coagulation, and this thrombin does not absorb the fibers with the antithrombin 3. Now the bleeding disorders. Liver disease can depress the clotting system. Vitamin K deficiency also lead to the serious bleeding tendency. And there is also a hemophilia, which is an abnormality of deficiency of factor 13 and factor 9. And there is also abnormality is located on the sex chromosome 10. This is a genetic factor which will cause the hemophilia, common factor. Then there is a purpura. Purpura is a group of disease that occur due to the thrombocytopenia, which is a less level of the thrombocytes in the blood. Now another, that is a blood coagulation test, or will be there is a bleeding time, coagulating time, and prothrombin time. These are different time from where we can help the stoppage of the bleeding, internal bleeding, and clotting time will show us the time which will form the clot formation, generally 2 to 8 minutes, and last is the prothrombin time. It is the fastest time for the coagulation to take place, that is 12 to 16 seconds. Now anticoagulants. There now, if the coagulation is formed, there are some of the special drug which is known as the anticoagulant, which we can give in vitro also, in vivo also, with the help of the sodium citrate, potassium oxalate, and EDTA. Heparin is also one of the important anticoagulant which we can give in vivo also and in vitro also. And last is the vitamin K agonists such as Jumalicol and warfarin, which is also a stabilized anticoagulant, and we can give it as in vivo by IV. Now these are the references from where I made my presentations. Now thank you.